Good evening, everyone. As I said, this is Thota Sivasankar, and I will be discussing in the today's session about the drone data processing for 3D mapping and modeling concepts. So, in this drone data processing, one has to understand, the both system requirements as well as the sequence of steps that has to be followed. And while processing the drone dataset, what are the aspects that has to be taken care, and how it is going to impact the outcome, basically the 3D model, what we are going to design. So in many ways, this 3D modeling is one of the uh, important aspect that has been researchers working on, including the government officials. They want to build a 3D urban modeling, as well as further many
Sir, your voice is not audible.
hello. Can you please confirm? If you can able to hear me?
Yes, right now.
Yeah. Okay. Okay. There is some network issue at my end, and as of now, there is some fluctuation is going on. So there might be some hindrance. In case of if I get disconnected and some sort of topic covered, please let me know so that I can repeat the topic. Uh, so as I was discussing, 3D modeling is one of the important aspect that researchers as well as government organizations and various industries have been working on. And so in my presentation, let me first try to start with the introduction to the drone data set, like why it is has been so important, and like how it is actually unique in comparison with the other remote sensing data sets. Let me first speak about those in those lines, followed by what are the different softwares available for the drone dataset processing. And in this particular session, we will be working on one of the one drone data software, which is AGI Soft Metashape. So let me, try to introduce you, with the AGI Soft Metashape. And if someone would like to access the, I mean, use this software, for data processing, how to download it, and what are the, what type of modules available in the AGI soft, that we will be exploring later on, and followed by the drone data processing steps. So in which we take a sample data set, further, follow, try to process the data set in the AGI soft uh, in the recommended, steps, so that we will have a look at it. So the first aspect is why drone data has unique. It has importance and uniqueness. In the recent days, everyone is speaking about the drone data set. So coming to the remote sensing data set, most oftenly people, are well familiar with the satellite imageries, including, aerial photographies to some extent. So whereas, the drone photogrammetry has come recently into the picture, and the main purpose, while capturing any imagery from a camera, even, you must have observed, through by while using your own mobile phones. So while taking any picture of a particular object, so you usually, as you move closer to the object, you could able to get the higher resolution, and more information about that particular object, because of that high resolution data set. So as you move away from the object, you certainly end up with a moderate, or the coarse resolution that you usually get, which may have little less information regarding that object, or the phenomena. So as you can see, the satellites are being at the at far away distance from the Earth's surface. So they usually be able to capture the information to the best extent it is possible with the satellites sees off. about, 0.5 meter resolution to the 1 meter resolution. Typically, you can get in the multispectral region. So whereas if you consider the aerial photographies, where through aeroplanes or flights, the images have been captured. So these altitudes are little closer to the Earth's surface, because of which it usually gets the high resolution data set. In comparison with the satellite imageries. So in generally, in the real world scenario, so most of the satellites, before they launch it over the satellite, before the sensors been uh, mounted over the satellite, they usually be mounted and captured through aerial photography and calibrated and tested, before it's been launched to the satellite, mounted and launched to in the satellite. So whereas in the recent years, the emergence of drone photogrammetry, and this has come into the picture as the drone technology has been emerging significantly. Uh, so this has been one of the primary data set, to capture high resolution data sets. So even the government of India has been executing various missions in which they are capturing high resolution how high resolution imagery from drones for various villages across India. So in this case, while capturing the drone datasets, as it is far is really close enough to the object on the Earth's surface, so it could even capture the information at centimeter level precision. So that certainly gives us a more detailed information that includes, a person walking on a road. If you can take a photograph from the drone, even, you could able to recognize, the person as well as, the object. Let us assume, there is a vehicle on the road. Even, you could able to get the information about the model information of the vehicle, and even the registration details and all such informations can be captured from the from the drone data sets. So those are the few advantages that you get it through while if you can go with the drone photogrammetry. So the complications that you usually get it in the drone data acquisition process, as you have to capture it at very close to the Earth's surface. So they usually have uh, the situations, may not be reliable or the comfortable in every situation, and you may don't get the like in the way that you get it in the satellite data set. You get, the entire the data set, across the globe, over it, in a repeated manner. So such kind of, aspects, you won't be able to get it in the drone photogrammetry, drone data acquisition process. These acquisitions has to be made as per the demand, as per the requirement. So it can only be captured over a smaller area rather than at the larger areas. So those are, few limitations, you usually observe while working with the, while you look at the drone data availability across the globe. And coming to the acquisition process, so this acquisition process may not be such comfortable, because if there is any extreme weather conditions like having the flood scenario with some windy situation, or maybe is it if it is a raining situation, or some extreme weather conditions situations, it might not be feasible to capture drone dataset over some specific areas. So those are, few limitations or the constraints, to while the in the capturing process. So that may probably, these aspects, could be uh, discussed or elaborately like emphasized, in the other topic in the other session, I believe, by the which is going to be taken by the Dr. Abdul Kaish Kanungo sir. So these are the few aspects, regarding the drone data acquisition aspects. So coming to the softwares, there are, n number of softwares available that enables you to process drone data. So usually, one may get a question regarding, as there are softwares, which we have been using for satellite data processing, can't we use directly those softwares for the drone data set processing? So it's simply, simple answer is no. I mean, you can't actually directly use the same software for the drone data processing. The reason, one of the primary reason is, as these are very high resolution data sets, it requires a different processing mechanism than what we have been following in the satellite data processing. So because of which we need to have a different softwares or the tools that can help you, to process these satellites in a specialized platforms. So a few of them, as you can see over here, Pix4D is one of the popular or commonly being using. Even, ArcGIS has come with the, drone data processing tool and drone mapper and various, other, all these are, few tools which can help you, to process or, makes you enable, to process the drone data. And particularly, what we are going to work on in this particular session, or what we are going to look at the drone data processing demonstration process is through AGI Soft Metashape. Soft. Coming to the AGI Soft Metashape, so it is one of the commercial softwares. As in many cases, you may find the drone data processing softwares are most of them are commercial. The paid version, and there are few softwares which provides you uh, a free version, but by making use of the command based instructions. Like, if you are comfortable with coding, you can start making use of the free version softwares that helps you to process some sort of process the data set in a proper manner. If you are not comfortable with the programming aspects, then it is advisable, to go with the commercial softwares, which has GUI based platforms or the tools that makes life easy, to process the data set. One of which is AGI Soft. And this AGI Soft helps you, to generate, 3D spatial data set. And further, it is also available for a trial version of, 30 days. So one gets exposed. If you just want to try once and explore it, so certainly, so let me just show you, the soft, how to get this AGI soft download. So AGI soft, Metashape has come with various various versions that includes, the professional version, and there is a professional education standard version and professional educational version. So there are, different types of versions which are available for the download point of view. So you can just, search for the AGI soft Metashape. In the download section, you could able to visualize there are, multiple versions in which, whichever version you are comfortable, one can go with. And whereas, in particularly in this particular demonstration process, we are going with the AGI Soft Professional Edition. So if you want to download it and if you want to make use of the 30-day trial version, you can simply go to the Get Started, and it is going to ask you, to provide some basic information regarding your email ID and regarding your name, email ID, as well as, further the affiliation, which institution you are associated with, and mobile number. And once you complete this process and submit the information, place the order, which is costing of, $0 USD. So no cost, for the trial version point of view. And you don't need to provide any sort of, credit card information. So I mean, like one can use, I mean, for the 30 days version. And if you want to purchase it, I mean, then you can go for it. Otherwise, you can discontinue the version and I mean, go for the different softwares as well. So those kind of, I mean, like flexibilities, I mean, you get it with the AGI soft. And once, I mean, you download, you complete this process, you usually, I mean, get a code along with the link information to download, I mean, the specific software. I mean, there are, I mean, different sort of, I mean, softwares installation, uh, like the softwares, I mean, available at different extensions. Like for the Windows point of view, I mean, you get the MSI version, and whereas, I mean, for the Mac and other Linux versions, I mean, also been available for the from the AGI soft. So this AGI soft, I mean, Metashape. So it appears in your system. If you once you install the software, you could able to get the details about the AGI soft under the Windows section. I mean, if you go to the all softwares, one can visualize the AGI soft. I mean, once it's been installed in your softwares in your systems. So if you just, I mean, open the AGI soft, you usually, I mean, get such kind of, I mean, dialog box and followed by such kind of, I mean, uh, the space, I mean, in which, I mean, that you are going to work with. Okay. So let me just, I mean, I have just cleared the console. So if any processing been carried out, I mean, in the previous sessions, so those versions have been available in the console details. So that we try to clear those without having any, without uh, creating any confusion for my processings. And on the left hand side, I mean, you can like at the first instance, I mean, if you look at the top level, you get the drop down menu in which, I mean, you in the file version, one can go with, I mean, if you want to open a new window, in such cases, I mean, you can go with, if there is a saved version, I mean, one can go with the saved version to open through this open option. And these are save and save as, I mean, which are often been used, I mean, in many of the applications, including, I mean, the export and import point of view. Once you process the data set, I mean, if some specific data you would like to export it in a specific manner, where, I mean, you usually use these tools. And whereas, I mean, the other drop-down menus, I mean, where you, I mean, as a drone data processing analyst, so that you may have to know more about the workflow point of view. So where you are going to make use of a few tools under this particular section. So this is going to be useful for our drone data processing. And whereas, I mean, the other tools which are helpful to further improvise the drone data processing, that we will discuss, I mean, as we go into the details of it. Okay. So for this particular session, we have started making use of, I mean, we have considered, I mean, one of these sample data set that's available from by the ArcGIS drone to map, I mean, which is one of the software, I mean, for the drone data processing. So they are providing a few sample data sets, I mean, for for testing the processing as well as to get a basic hands-on experience. So we have considered, I mean, one of the sample data set which is available from this particular uh, data. Okay, so we have considered, I mean, particularly uh, this information, the rapid information, which consists of about, I mean, 21 images. So which we will be working on. So let me just show you, I mean, once we downloaded this data, I mean, how it is actually appears. So the sample data is available, I mean, in this particular folder, which is of, I mean, sample asphalt, which has, I mean, one folder along with, I mean, two additional additional informations. So if you go into the details of images, you are having a total of 21 images which have been captured by the drone, and I mean, in in a uh, in a specific pattern. Okay, these patterns varies, I mean, for different, I mean, there are different patterns in which one can capture the drone data set. So there are, I mean, like with a plain manner, one can, I mean, capture this, one can capture it. I mean, if you're working over a like a little uh, planar surfaces, having, I mean, undulation in it, I mean, the minor undulations in it. Whereas, I mean, if you are working with any like buildings, then I mean, the capturing, I mean, the way of, I mean, capturing is, I mean, little circular at, I mean, with the different altitudes. So those informations, I mean, you can see it, I mean, while working with, I mean, in the AJS software. I mean, we will discuss later on. So along with the 21 images by the drone. So we have, I mean, two additional files. If you just, I mean, if you can have a look at it. So it has details about the coordinating points, control points. These control points are being captured, I mean, for to improvise the drone data processing, as well as, I mean, to improvise the geo-referencing of this process data set. So we need to have a few ground control points. So these ground control points are uh, been identified, I mean, for an optimal optimal locations have been identified. And for these optimal locations, I mean, I mean, we have you, one may use, I mean, uh, the GPS, or I mean, uh, the differential, I mean, the GPS, I mean, so these sensors, these instruments helps us to get the precise or accurate location information of that particular point. So such identified points, I mean, in this case, I mean, it has been provided with 11 different GCPs, for which the DGPS, the information being captured, uh, I mean, along with, I mean, few notations, and which have been separated with a comma, so that which you might, I hope, I mean, all of you could able to visualize this information. So in the other file, which is of, I mean, CRS info, which consists of coordinate system, like in which the data has been captured, and I mean, as per the location, it has been provided. Okay, so once, I mean, I mean, let us move to our software, which is AGI Soft. So this AGI Soft is going to have, on the left hand side, I mean, one can see there is a workspace with a chunk. So this chunk is the place where we are going to work. Okay, so where we start like importing images, and I mean, further processing. So which what everything, I mean, we are going to do within this chunk. Okay, so let's start, I mean, with this workspace one. So the first aspect is we need to add photos. I mean, photos to the, I mean, images, drone images to this chunk or the workspace. So for which, either, I mean, you can go at the top, I mean, you can see the under the workspace section, you could able to see the, if you want to further add, I mean, few more chunks, I mean, that you can add, I mean, the chunk. The second option is of add photos. Either, I mean, one can go with this particular option, add photos, to select the images, I mean, what you are going to work with. Otherwise, you can even simply go with the workflow, which is one of the easiest way. I mean, I would say better to go with the workflow drop-down menu, so that it would be easy for you to process in a sequence manner. Okay, so the first step is of to go with the add photos. So once you click on the add photos, you could able to select, I mean, the all 21 photos, or I mean, you can even select, I mean, the uh, limited photos as per your requirement, so that can be further processed. So I have selected, I mean, in this particular case, I have gone with the all 21 images. If you can see it, I mean, as soon as, I mean, we add these 21 images, I mean, that been visible in the workspace section. So the workspace section, you can see, I mean, there are these images have been visible. I mean, if you just double click on each one of it, it is going to show the each images, I mean, how it's been captured, and which areas have been it's been actually captured. Okay, so in the left hand side bottom, So you can see, I mean, there is a workspace and the reference section. So if you go to the reference section, what we are going to get it is going to show us for each image with some sort of latitude, longitude, and altitude information, which is basically during the acquisition process of this particular drone data. So the sensor, at what position or the location the sensor is actually located. So that information being captured over here. So for every imagery, you're getting such information uh, because I mean most of the drones are equipped with inbuilt GPS, so that system enables to get the precise information as per the system accuracy what the drones are having. Okay, different drones may have, I mean, different accuracy, uh, I mean, feasibility to get such information. So this is, I mean, some sort of basic information or the initial data which may help or I mean, which may help the software to further process in a easy manner. So if any such additional information is there, I mean, that you usually get it in this reference information. Okay. So alongside, you can also get the additional information, which is pitch, row, and yaw. So this is basically this while the sensor been capturing. So in what at what angle the sensor is actually looking at. Okay. So it's basically the rotation along the x-axis is being called as is being considered as the pitch, and whereas if there is any rotation happen along the y-axis, so that's been like recorded under the roll. And whereas, I mean, if there is any rotation being happened in the Z direction, so that's been captured at the yaw section. So these sections, I mean, if the sensors are capable enough to capture, I mean, such information, they usually get it, I mean, by the camera itself. So as soon as, I mean, you import the images, so in most cases, I mean, you get these informations directly. If you have, I mean, such information as a separate file that has to be calibrated before processing these images. Okay, so those are the few aspects, I mean, before you start processing it. And the first and foremost thing that we have to do it is, so we need, once, I mean, we add these images, the first step is is to go with the align photos. So while aligning photos, it is going to handle it's basically going to handle the correction and identifying the tie points between the images. Uh, I mean, based on the information provided as based on the interior and exterior parameters of the camera. I mean, of the sensor. So basically, okay. So coming to the interior uh, parameters of the drone dataset, so which is of the focal length of the camera that's been used over the drone, and I mean few other distortions. I mean if there is any if there is any such details been provided about the camera, and whereas the exterior distortions, I mean, are including uh, basically, I mean, providing the information about the location, which is being provided in the under the latitude, longitude, and altitude section, along with its along with the angular information during the acquisition process. Those details, I mean, will be used or like estimated based on, I mean, the information is available to the system, and it is going to further process to identify few type points as well, key point as well as type points. So let me first, I mean, show you like what are these. So the under the, I mean, as soon as, I mean, you ask to go with the align photos, there are, I mean, few information uh, that you have to define before, I mean, you go with the process. So few one such information is of accuracy. So under the accuracy section, you could see there is a highest to the lowest category one could go with. So what actually happens? So while processing these data sets, it's going to provide us the final outcome as a key point, which is basically it is going to identify some features in each imagery which are existing commonly in different images. So that's what we are going to identify type as a type point that we call it as. Okay, so to identify these features, so at what accuracy one would like to go with, so that is supposed to be defined over here. So if you go with the highest approach, basically you actually scale up the original imageries by 4 factor. So which is like if 1 pixel in the original image is going to be further divided into 2 by 2 pixels. So you get a better accuracy. If you go with the highest accuracy. Okay, and whereas the limitation would be you may need to have a good high-end system or the workstation to process at the highest accuracy level. And whereas high level is basically it is going to work at the same resolution what our original uh, drone data is available. And whereas if you go to the medium resolution, you are actually scaling down. Like you are actually going with the 2 by 2 pixels of the original image is going to be clubbed as one single pixel. Okay, so uh, that happens. At the medium resolution. As you go to the lower level, further 4 factor has been downed. So you get 4 by 4 pixels are going to be considered as a one single pixel while processing it at the low level. And lowest level, furthermore 4 factor, you are going to scale it down. So by doing such kind of scale down process, the limitations you will find out is it is you won't get more number of points, and it is very difficult to get high precision if you want to go with if you while generating the 3D model. So it is recommended to go with the at least high, or if you are working with a little uh, complex data set, in such cases one can go with the highest approach as well. Otherwise, if you just want to get a simple idea about the area, just get the simple process to be done faster and get some idea. In such cases, one can go with the further, medium or lowest sections as well, accuracies as well. And the pre-selection process, you usually the under the accuracy section, like you are getting the pre-selections and reference pre-selections, which are basically going to uh, I mean get the information about uh, the information about the camera that is available in the data along with the data set, whether to be considered or not. Okay, so that information is going to be used as a generic pre-selection. For example, like if a point in a particular image been captured, uh, a particular object is being captured in different drone images. So in such cases, based on the location information, one may get an idea about how the data is actually been uh, like placed. So based on this information, if one object is available over a particular image, it's going to be easily monitored. Uh, alongside of those the location, so that you get a generic pre-selection process happens. And whereas reference pre-selection, if you want to just follow the source, you can go with the source, which is what the information that is available. The otherwise, if you want to go with the estimated case, it's basically like once you do the align photos, and there must be once you do the ln in the first instance, if you go with the ln photos, you are going to have the estimated latitude, longitude, positional, as well as the angle distortions being measured. So if you want to make use of those estimated the measurements or the parameters, so then you can go with the estimated. Otherwise, there is a sequential process in which irrespective of the the information, it is going to be considered the sequence in which the images have been like added to the software, and it is going to be followed in a sequence manner to match a key points, I mean, with one with the other. Okay, so these are the few aspects, I mean, that you may have to be selected or enabled, I mean, during the data processing. And there is, I mean, few other information if you go at the advanced section. So that includes, I mean, key point limit and tie point limit. So which is in a particular imagery, how many maximum number of features has to be identified, the locations. So that has been set up, I mean, defaultly at 40,000. If you want to further increase or decrease, I mean, one can go with, if you set 0 for the key point limit, that is going to be identified uh, the, I mean, infinite number of key points per image. So that may lead, I mean, some difficulties because while you are identifying key points, the few of them must be having a, I mean, good accuracy. I mean, it's more strong to consider, whereas, I mean, few other might not be such strong enough. And if we are going to consider even the weak key points in an image, that may actually mislead our 3D modeling concept. So better to go with the optimal number of key point. I mean, define, I mean, a specific number of, I mean, key points, so that, I mean, you can actually control the accuracy or the confidence level of these key points, uh, I mean, in the while in the processing. And further, type point limit is of 4,000. I mean, when, I mean, you're trying to finalize, I mean, how many type points, I mean, to be identified across the images. So that is of that has been defaultly given as, I mean, 4,000. Over here, I mean, if you set 0, which means, I mean, it is not going to consider not even a single type point uh, between images, I mean, which is not recommended. So go with, I mean, a good number of type points. If you start increasing the type point information, it may even consider the low confidence key points as a type point. So better to limit yourself uh, to such a number based on the picture or the area that on which the drone data been captured. For example, if you have captured the drone datasets over the strongly distinguished features, okay, like urban. So in such cases, you may identify, I mean, more number of features. Whereas if you capture an imageries over uh, forestry or, I mean, agriculture crop area, then the features on in the different imageries are often been similar, and it may actually get the lower confidence level information also while going with the key point generation. So such key points, I mean, has to be, I mean, like one has to take, I mean, based on the area on which, I mean, the image has been captured. I mean, that's one of the primary aspect. So let me just, I mean, start um, just executing the align photos. It usually take, I mean, little time. So as you can see in the details section, so the GPU has been, I mean, one GPU is found, and I mean, it's started processing. So each photograph, I mean, been given with a reference, and I mean, the number of points that's been generated for each, I mean, as a key point. And once the key points have been identified, so this is further being processed to identify the type points among the images. It may take, I mean, 1 or 2 more minutes, I believe. So yeah, now it's done. Now you can see there are all these are, I mean, basically the key points. I mean, how it's been generated for different images. for different images across the scene. So this is our scene coverage with, I mean, some sort of, I mean, spherical structure, I mean, which enables you to rotate the scene as per your requirement, I mean, for better understanding. Okay, so if you want to see the image, sorry, if you want to see, I mean, the sensor positions and the image information, that you can see it over here, which image, I mean, the image, I mean, label is provided along with, I mean, the positional information, how the images have been captured. So based on this information, what if any specific image you would like to remove it, I mean, from the data set, then, I mean, one can go with it. I mean, if you don't find, I mean, it's more useful, I mean, worth to go with, or I mean, you can even exclude it, I mean, to further process it. Okay, as of now. So, and the top, I mean, you can see this camera, which shows, I mean, shows cameras. Okay, if you don't want to visualize, I mean, these cameras information, you can even disable it, which is going to enable you, which is going to provide you with such such surface along with sort of, I mean, there's some sort of, I mean, information about uh, the structure, I mean, how it's been distributed. Okay, so as you can see over here, so the structure is clearly showing it's more of, I mean, flat, I mean, with few undulated terrain, I mean, along the, I mean, along the flat surface, and the points are, I mean, actually falling within the frame, which is actually defined it. If the frame, if any specific information or, I mean, specific key points which are actually going beyond the limit, either, I mean, you can adjust this particular dialog box, or, I mean, you can even further delete, I mean, those images for further processing. Okay, so those are the few advantages that you can get it in over here. And in case, I mean, one way of, I mean, doing the process is without considering the ground control points, you can directly further process it based on the information, I mean, the camera locations, while capturing those images, or as it's already been collected, you can directly further process it, I mean, to get a geo-referenced digital elevation models. However, if you want to further include, I mean, increase the precision or the accuracy of the digital elevation models, so in such cases, one can even go with the adding, I mean, few more control points, ground control points, and that may enable you, I mean, to uh, get, I mean, get a more precise geo-referenced digital elevation model. So to import it, so you can just, I mean, go with this reference data, followed by you can just select the control points, I mean, what you would like to go with, and you can over here, it's been actually like recognized. The data is of, I mean, NAT 83 Alabama East, I mean, which is matching with our coordinating system, what is recommended, I mean, for this particular data set. Okay. And along with, I mean, there are few labels information followed by the latitude, longitude, and altitude information. Okay. So this information, once you click on it, I mean, it is going to be further added to my list, okay, as a marker. So if one would like to go with, I mean, would like to make use of these points to further improvise the georeferencing concept, I mean, one can go with. Otherwise, I mean, you can even exclude it, I mean, further from the process. Okay. As of now, I'm not going to include this process because it may uh, take a little more time, I mean, to adjust, I mean, all these ground control points over the drone data set. Okay. And the next process is to go with, after the align photos, you have to go with the build model. Okay. So this build model concept, I mean, we first take back you to the imagery workspace. The first type points, I mean, we have generated over here. I mean, we have zoomed in, and then let's go back to workflow. next step is of build model. So this build model is basically going to generate a 3D mesh aspect. So this mesh is going to have a few polygons. It's going to be created. So for which we have considered the source data as type points, which we have generated in the previous step. Okay, so these type points have been going to be considered to arbitrarily generate a 3D mesh with a face count of 90,000, which is of if you want to go with the more number of points in a points to be processed, more number of polygons to be processed and at a particular in a particular area, then you can go with the higher. Or if you want to have a little coarser resolution, to have less number of polygons, then you can even go with the lower face count, which is not recommended. If you want to get a higher precise digital elevation model. So I'm just going to set up few additional informations like interpolation. If you would like to, it's a recommended one. To go with the enabling process. And however, if you want to uh, disable it, one can go with it. However, the difference would be, so once we have enabled and processed the data set, as you can see that the 3D mesh, the model, what has been built up. So it is actually uh, interpolated alongside of this scene based on the type points which are generated. Okay, so if you are not going to, if you are disabling the interpolation section, in such cases you are going to have a point cloud information as the type points are being generated. This point information only been generated, which may appear as a cloud aspect. Okay, and followed by, so once the cloud points have been generated, you can further add on the texture information. So this texture information is basically is going to be considered from the diffuse map, and the source data is of images. It's basically the the model has been built up, but there is no color information or the texture information being provided for this particular model. Basically the mesh. Okay. So to add the structure, the texture up to that particular 3D model, the 3D mesh. So we are going to use this particular build texture tool to provide the information. So the color information is going to be considered from the images which we have uploaded in the initial time, and which were even further processed. To the aligned. Those photographs. Okay, so that is what going to be considered. To get the textural information. Over here, the texture size, if you, I mean, as you get increase it, you get a larger scale of, colors. Okay, so that's one such aspect. And if you go with the advanced section, you can see that there is a enable hole filling and even enable ghosting filter. So what actually deals with? So if you start enabling hole filling, in case of any specific area has not able to capture or interpolated properly. So if there are any holes in the imagery in the model, those will be filled by the by this build texture automatically. And further, this enable ghost filter is going to help us uh, to identify any moving objects while capturing the drone data. For example, if a human being is walking or running uh, on a road, and the data being captured, so this moving object may have the distorted information uh, in different images. As you start building the 3D model, it may actually provide you a inaccurate information. So to minimize this uh, com this complex this uh, these difficult areas or the difficult objects. So we can start enabling ghosting filter. I mean, wherever thin objects are being available. So such objects have been discarded. I mean, if there is any distortion uh, in identifying the key points or the tie points across the images. Okay, so those features are going to be removed from the process, and it is going to be provided some texture based on the standard features. Okay, so once you click on OK, it is going to generate the textural information. One can see the process of the progress of the textural, how it's been processing. This often usually takes little time as you start going into the next level. Uh, like it's it usually take a little more time. I mean, as the accuracy gets increased for the particular 3D model what we are working on. So it may likely take, I mean, 1 or 2 more minutes, and so in few systems, I mean, this may even take little less time. That depends on the system configuration on which you are working and the number of scenes that you are working. So it could be of, I mean, any of these two reasons. I mean the processing speed depends. Yeah, I think, I mean, it's almost done. So now you can see there is I mean, the information uh, is clearly been provided by with all the textural information. The initial model, what you have observed, is a basic mesh model. Like in this current scenario, I mean, you can see the features have been picked. The textural information of the features been picked up from the images, from the drone dataset, and been provided. I mean, you can see. I mean, there is a vehicle over here. There are vehicles over here. But I mean, if you go into the details of it, I mean, the information is not clear enough. I mean, which is of, I mean, little broader sense. I mean, the information being captured. I mean, the model being generated. So this has to be further fine tuned to get a more precise digital elevation model. Okay. So now let us try to go with the next step, which is build tiled models. So in which we are going to make use of, I mean, the type points which we have generated initially, and further, I mean, you can define the quality. I mean, from the type points point of view, I mean, it's a standard quality. I mean, you are going to get it. In which one such information you are going to get it is the pixel size. At what precision the information is going to be provided. So which is often in meters. So point triple zero, I mean 17. Okay. If you go to the centimeter level or millimeters level, I mean, you could able to get such kind of information. Almost, I mean, 0.1119 millimeter pixel size. I mean, it is going to build a, I mean, this tiled model. Okay, so basically in the previous build mesh aspect, so we have actually generated, I mean, a few polygons that has a little broader structure, and these structures are, I mean, further divided into further getting, more precise 3D model for each such sections. So that's what, we are going to work on in this particular uh, like tool. And the tile size, if you want to define it, this is of the pixel number. So if you want to define it, the lower to the higher level size, as per your requirement, one can go with it. So it's recommended, to go with the lower size, lower tile size, which enables, the better 3D picture, for under each polygon of the mesh. And in addition, you are going to have a few other additional information. Just give me a minute. I need to, connect with my charger. Let me just, this process usually take little time. So let me just start the process and yeah, before I do this process, I need to save this information. Okay, once I save it, I can go with the build tiled model. And if you want to enable the ghost filtering, as I said, the tiny features, been discarded. If there is any new moving objects are available in this particular drone data. Okay, so I'm going with the process. Can you just, give me a second so that I can just connect it with my charging. Yeah. Yes. So this process has to take usually take, little longer time, as it, I mean, as it is going to build the texture, from the building textures information to further getting a better 3D model. Almost 77% has already been completed. It's going to take, one more minute, it seems. let's see for one more minute. If it's not, if it is taking, I mean, too long, I mean, we can open the already the processed imagery. Okay, so the tiled model is completed, and now you can see that the area has a better 3D representation. Okay, so which is going to be further improvised. I mean, while as we move on to the next process, which is, I mean, the generating the point cloud data set. So from the build tiled model, what we have done it over here, I mean, to further trying to improvise the model. So, uh, I mean, we will be identifying the points, the cloud, we are going to identify the precise 3D points with a better confidence. And these points are going to be further used to finally develop the digital elevation model. Okay, so for which, I mean, the build point cloud has to be gone through, in which we have, I mean, one can go with the information what we have. So as of now, I mean, we have already tiled model. So I'm going with the tiled model, and further, I mean, providing the uniform point spacing in the meters, I mean, I have given. So it's going to be 10 centimeter information. Okay. And estimated point count, I mean, could be of, I mean, 342, I mean, per image seen. So such informations are being defined, and we are further going with the point cloud building, and it has, as you can see that there are, I mean, 303 points which have been identified across the scene, and these points are actually distributed, I mean, at different heights. I mean, you can see it over here on the x-axis. And for these points, we are going to with work to develop digital elevation model. So while working with the digital elevation model, I mean, one may have to define in what projection that you want the final imagery, and what information you are going to use it to get the digital elevation model. In the previous processing data processing step, we have generated, I mean, point cloud, which we will be using it over here as a source data, and for the following providing the interpolation enabled, so that uh, I mean, other than these cloud points, I mean, the space, I mean, in between the cloud points are also been going to be interpolated based on the elevation information what these cloud points are having, and further adding the textural information. So that that's going to be, I mean, enabled over here. I mean, if you disabled, I mean, it is going to only consider, won't be able to interpolate the spaces in between the points. Uh, Let me. These points are not sufficient enough. I mean, we can go with the, uh, I mean, rather than going with this cloud point, I mean, let us generate, I mean, the cloud point in a different way. So I'm going with the depth maps rather going with uh, the tiled model, because of which is going to provide me very less number of points, which is not able to get the digital elevation model. So let me generate the through the depth map. As we are going to get the more dense point cloud information, usually this process may take a little longer time. So better not to go with the such lengthy process. We can stop over here, and we can reopen the already the process data set, rather uh, generating it from here itself. Let me just open a project, which we have already done that. So this is one such. So over here, we have already generated the point cloud data through depth maps. So that has come about, 3 lakh, 39 lakhs, 63,514 points, 14 point cloud data sets. So this information is going to be used to generate the final the digital elevation model. So that's why it is going to be helpful. Rather, you can see over here, even the objects are clearly visible, and even the elevation patterns are been provided, effectively. Okay, so now the process is of to generate the digital elevation model, for which we have to consider only the ground points, because the all other objects are not actually the man-made constructions are any other objects usually not included in the digital elevation model. Okay, so only the earth surface information is considered. So for which we have to go with the digital elevation model, and further as I said, you have to provide the projection, the appropriate projection information, along with which data you are going to make use of it, to generate the digital elevation model, and whether you want to enable the interpolation or not. That information has to be set. It is recommended, to go with the enabled interpolation, and further finally processing the data to get the digital elevation model. So as soon as you double click on the digital elevation model, you can see, as per the texture, the color code information. The color code represents with the 240 meter to 250 meter. Okay, the lowest possible elevation is 240 meter, and the highest elevation is of 250 meters. So that's how it has been generated for each pixel information is provided over here. Okay. And further, one more product can be generated, which is of ortho mosaic information. So for the normal mosaic, and the ortho mosaic, there's a significant difference. So in the normal mosaic, while you are working with, so you are actually just uh, like stitching the satellite images. One with the other. However, when it comes to the auto-mosaicing process, so the images have been stitched to maintain a consistent spatial resolution, irrespective of the elevation or the altitude the feature belongs to. So those are the, it's one of the uh, standard product that often, I mean, people work with, like particularly, I mean, when you are working with hilly terrain, or I mean, if your study area is of having some undulations, in such cases, it is always recommended, I mean, to go with the orthomosaic to get a more precise spatial information and the dimension information of the any specific area or object length or height information. So to go with, I mean, we can, I mean, simply, I mean, run this built orthomosaic, which consists of, I mean, the surface information digital elevation model, I mean, what has to be provided. And I mean, the model, I mean, which we are going to work with is the mosaic build-up model. And there are, I mean, few options that one can enable. If there are any ghost filters, I mean, that you would like to enable, such filters, I mean, can be enabled, or otherwise, I mean, you can even disable, I mean, as per the requirement or the uh, requirement of the data or the specific project. Okay, so once we start running this auto mosaicing process, the final image we are going to get it is the it final 2D auto mosaic image. So the process completed. If you look at the final product of the auto mosaic, I mean, this is how many it appears with the high precision and having the consistent spatial resolution across different altitudes. So the products, I mean, over here, if you can see, one such information is of a digital elevation model and 3D model, what we have generated, and the auto mosaic information. These are the few like important products when you are working with drone data processing, drone data set. Okay, so this even, I mean, further help you, I mean, to I mean, further analyze it in various application that includes agricultural applications or even the construction, civil engineering point of view. I mean, the construction, like building constructions, and to further monitor, I mean, highway constructions. All those, I mean, aspects can be carried out effectively through drone data, and you could get the actual the realistic picture of the area without going to that particular location physically. So those are the few advantages, I mean, one can get it if you start working in on the drone data sets. Okay, so this is all from my end. If any specific queries you have, I mean, we can discuss on those aspects. Hello.
Yes,
Hello.
yes, it's audible.
Yeah, I mean, this is all for regarding the drone data processing. So if there are any queries from the participants, I mean, we can discuss, I mean, those, I mean, and finalize, I mean, uh, the
Can we
session.
count the number of vehicles and all using? I mean, using this basic, image. I mean, without motion, can we just identify randomly without
Yeah,
errors?
yeah, I
Means
mean, as I said, I mean, it is,
there is no clarity if the drone is of less capacity. I mean, we have normal drone. When we take images, it's mostly like blur. Can we quantify? I
Mhm.
mean, can we extract it perfectly? Classify like what? How many cars are there, or not like? I mean, is there any tool for
So,
no, images to get the exact data without some errors in classification?
okay. So the first thing is, I mean, if you have a, I mean, little smaller drone, like, I mean, the data usually comes in a blurred manner. So there are, I mean, the blurring uh, is actually impacted on two aspects. One is while you are capturing the drone, okay, I mean, while your drone is flying to capture a data, so the drone has to be uh, in a speed of lesser speed in comparison with the shutter lens shutter speed. Okay, so every camera is having a shutter time. So it usually takes some specific time. Okay, for example, I mean, a particular uh, camera, I mean, or the sensor, you are using it over the drone, which is of having, of, I mean, of like, let us assume, I mean, 0.5 seconds it takes, I mean, to capture the entire scene, okay, which is of, I mean, shutter time. So in such cases, I mean, zero point 0.5 second, within the zero point 0.5 second, the I mean, the drone should not move from one place to another place. I mean, if it is moving, I mean, with a high speed, then the possibility of, I mean, blur scenario, I mean, you may observe. Okay, that's one could be one reason. The other way around, I mean, if your camera is of lower resolution, which is not of, I mean, higher resolution camera, and you are actually capturing the scene information from a longer distance. So that could be possibly, I mean, two possibilities. The blurring situation comes up. So if you can start resolving these two aspects, most oftenly, uh, there is a possibility that you get the better and quality, I mean, high quality drone data sets. Once you get the high quality drone data sets, as I said, I mean, this is one of such standard drone data sets. So you can even see that, I mean, the vehicle's information along with, I mean, the color. One could even identify the the model's information to some extent. Okay,
So in
so
this software
coming to the
only, can I just extract the cars? I mean, the cars are in different colors, different lengths and sizes. Is there
yeah.
any tool here that can just extract the cars by itself?
So it's basically you have to go with the object-based image classification. So you have to do segmentation. I mean, it's basically the way, I mean, that we do it over the satellite imagery is it's going to be the similar approach. Okay, so
Yeah,
the
but we
first
have
process is
to
going
just
to be
draw the line around the car, so it may take
Mhm.
huge time. Like object-based analysis, we just draw the line around the car and we just select in how. I mean, it's like object-based analysis, but it takes so much time. If induce some pixel like color type also, the road may also classify because here we can see that road is of same color as of car. So it may classify as of car if we go with the color. So, is there anything like, I mean, here in Agisoft, a tool or something, it gives out everything based on previous experiences like a deep learning or anything code is there to extract cards
see
automatically.
see as I said, I mean, the pre-trained model in the geospatial domain are very limited. Okay, that's because of the different sensors works at different electromagnetic spectral regions, and at different electromagnetic spectral regions, the same object appears in different way. Okay, so it's, I mean, usually, I mean, the process would be if you want to design a particular approach, I mean, the pixel-based approach is useless, I mean, from the drone data processing perspective, and particularly from the car's perspective, I mean, it is not recommended because, I mean, different cars may have different vehicles may have, I mean, different color composition. So it's always better to go with the object-based classification. I mean, one has to train the model. I mean, there is no such ready-made tool that you can go with. I mean, it's not only about the color. It's not only about the cars. I mean, you may not. Few other may have. I mean, few other requirements, like, I mean, going with a specific let us assume, I mean, there is a dump yard at the mining section. So maybe, I mean, the people would like to know the specific area of, I mean, the mining happened, or I mean, the specific object been there. So as per the requirement, one has to train the model and, I mean, further process it. This platform is only going to help you to the basic data that you have captured from the drone to get a standard product. As I said, I mean, there are few standard products, I mean, which is of, I mean, 3D model, digital elevation model, and orthomosaic. So these are the basic tools, I mean, that you can get it, basic information that you can get it from this particular model. And further evaluation or the classification has to be done as we are doing it in other softwares. Any further queries? It seems, I mean, there are some messages. Let me just check it.
Uh, that is regarding feedbacks.
Oh, okay, sir. So should I stop sharing the screen, or is there any further queries, I mean, regarding the tool or the drone data processing concepts?
So you can stop.
Yeah, okay. Thank you.
Thank you, Mr. Sivasankar. Hope we had a very good session. So requesting all participants to submit your feedback submitted in the chat box. Have a great day. Thank you.
Yeah, thank you. And I mean, I'm thankful for the opportunity been provided by the Babatla Engineering College, and particularly the Civil Engineering Department for this opportunity to interact with you all. Thank you all.